Welcome to Learning Chemistry with Faye. In this video, we're going to learn how to use the periodic table. Let's first look at the periodic table. The periodic table is full of patterns and information of all elements. Using this table, even just knowing the position of the elements, you can learn a lot about them. For example, the first column of the periodic table is called the alkali metals. The second column is called the alkaline earth metals. The center section are called transition metals. Moving to the last column, these are the famous noble gases. The second to the last column is called halogens. So knowing all this and just the position of each element on the periodic table, it can also help us determine the electron configuration along with the number of valency electrons for each element. But before jumping to that, which we will go over in future videos, let's first learn about what information can each element box give us. In each box, there is a number at the top left corner that represents the atomic number of the element. This number is also the proton number. The abbreviated symbol is at the center, and the atomic weight is at the bottom of the box along with its full name of the element. As we know, each element is made of protons, neutrons, and electrons. Protons are the positive charges, electrons are the negative charges, and the neutron are the neutral weight of the element. The weight of the element comes from the proton and the neutrons only, since the weight of the electrons are negligible, relatively speaking, in an element. All elements exist in neutral form on the periodic table. They can form charges and bonds and react with each other in the environment. Sometimes they even prefer to stay in a different state or charged state in the environment. However, in the periodic table form, they are all neutral. So if we know the atomic number of the element, which is shown at the top left corner of this box, it's the proton number, and the proton number equals to the number of electrons in the element. That's the only way to keep a particular element neutral. Then we can determine the number of protons and the electrons from the atomic number. Furthermore, the weight gives the sum of the number of protons and neutrons, since we remember that the element weight is made up of protons and neutrons, which means by subtracting the atomic number from the atomic weight, we can calculate the number of neutrons in the element as well. So from this box, we will be able to determine the number of protons, electrons, neutrons, and the weight of an element in addition to its symbol and its full name. So now let's try a few examples, see if you can determine how to do this through the periodic table. Using the periodic table at the bottom of the page, let's try to fill up this box. So as we know, the proton numbers are the same as the atomic numbers of these elements. So in this case, we have the example of a potassium, arsenic, and platinum. So let's first look at where they are. So using the position of where they are on the periodic table, we can actually just find them and fill up the boxes of the number of protons. We got potassium at the number 19, arsenic at number 33, and platinum at number 78, right over here. And of course, as we recall, the proton number in an element is the same as the electron number in the element, since all the elements are in neutral form on the periodic table. Therefore, all we have to do to fill up the number of electron boxes is by copying down the same numbers as the proton numbers. Now let's determine How to calculate the numbers of neutrons? As we remember, each box gives the weight, which is the atomic weight of an element. And that atomic weight consists of protons and neutrons. Since we have the proton number of each element, that means we can just simply use the weight at the bottom of the box to subtract the atomic number to give us the neutron numbers. So for example, with potassium, we have 39. Subtracting 19, we will have 20. And with arsenic, we have 75, subtracting 33, and we have 42. And the platinum, same method applies. We have platinum is number 78. We have 195, subtracting 78, and we will get 117. And the format symbol to represent the weight and the number of protons are these. That's written right here at the bottom. Okay, so these symbols simply gives you the number of protons at the bottom and the weight of the element at the top. So every time that we are talking about the weight of these elements at the bottom of these boxes, we call it the atomic weight. But what does it mean? Let's take a look at it on the next slide. The mass number is technically the total number of protons and neutrons for a given specific isotope. And the atomic mass is the weighted average of all the naturally occurring isotopes in the environment. However, for the most part, we actually use the terms mass number, the weight, atomic mass, the weight of element, pretty interchangeably. And when we use these terms, we're all generally referring to the atomic mass of the element. So what is the isotope? Without changing its identity, sometimes an element can take on different weights. This phenomenon is called isotopes. Their proton and electron numbers will remain the same, but the neutron number will change. There will always be a most stable form of the element. So in this case, we're giving the example of neon. And you can see that the weight of the neon can change from 20 to 21 and 22. And these are the mass numbers of that particular isotope. And we can also see that the most abundant form of neon is neon with a weight of 20, which is taking over about 90% of its existence in the environment. That means if you have 100 molecules, there are about 90 of them has the mass of 20 for neon, and have 9 of them that has the weight about 22. And only less than 1% of them has the weight of 21. So how do we take into account of all these different forms of neon to give the atomic weight of neon that exists in the environment? So what we do is we gave a weighted average. So here are the proton numbers, electron numbers, and neutron numbers of each form of neon. As you can see, the proton numbers all stay the same. So are the electron numbers, with the exception of the changing forms of neutrons. Let's take a look at how do we calculate an atomic weight of an element, which is the weighted average of all 3 forms. So we're going to use the following data showed in this table to determine the weighted average, which is the atomic weight of neon. So first we can see that neon 20, which has over 90% of abundancy, has the mass of 19.992 atomic mass unit. Okay, so the neon 21 has 0.27% of abundancy and with a weight of 20.994 atomic mass unit. And the third format of neon is neon 22, which has the atomic mass of 21, which has atomic mass unit of 21.991 at 9.25%. So how do we calculate this and average it? We can't just add them all up and divide by 3, because that wouldn't be fair, right? If we just add them all up and divide by 3, we're saying all 3 forms of neon exist equally, and then we're just simply taking all 3 of them, they all equal to 1/3 parts in the environment, and that is not the case here. So what we do is we multiply each of these mass by the percentage and then add them together. Remember, once you have this particular calculation, you do not further divide by anything because you had already multiplied the mass by the correct percentage that exists in the environment. And then we will get a final answer of 20.18 AMU, which is atomic mass unit. And a lot of times we also refer this particular unit to be grams, right? So in that case, we have neon at 20.18 grams as the atomic weight for this particular element. Let's try a different example. In this example, we have lithium consists of 2 isotopes. We're given the atomic mass unit for both isotopes, and we know the atomic mass of lithium from the periodic table, and we need to calculate the percentage of each one of these isotopes. Remember, whenever we are writing the elements in this particular format, the number at the top left corner refers to the total weight of that element. Okay, they're not atomic weight, but the total mass of this particular element. So what we first need to do is to identify the abundance percentage as X. You can identify either. You can pick lithium 6 or lithium 7 as your X. In our case, we're going to pick the lithium 6, which is a lithium isotope with 3 neutrons as our X. And naturally, both forms of your isotopes must add up to 100%. And remember that 100% is equal to 1. That means if your lithium 6 is equal to X, then your lithium 7 needs to take over the rest of the percentage, which is 1 minus X. To set up the equation, therefore, you have, remember, is the weight multiplied by the abundancy of the percentage, which in this case you have a 6.015, multiplied by X, which is your percentage, plus the 7.016 multiplied by the rest of the percentage. And that should give you the atomic weight of lithium that's written on the periodic table, and it's a 6.941. With algebra steps, if you're unfamiliar with it, please make sure you review until you're absolutely certain how to do these, following these steps, or without following these steps, you're able to get the answer of your X, okay? So what you first wanted to do is to bring these numbers out of the parentheses, so which is 7.016 multiplied by 1. And then when you bring out the negative signs, make sure when you're adding a negative sign, once it gets out of the parentheses, you have to switch signs. Okay, so that would be 7.016x.
Make sure you know how to do these calculations, how to do this algebra, all right? And the final x, we get 0.0749. But remember, we need to convert this particular decimal number into a percentage, which is 7.49%. If we had the format of lithium-6 at 7.49%, you can calculate the rest of the lithium-7, which in this case, we know that is the most abundant form at 92.51%. Remember, you can pick any one of these isotopes to be X. So if you pick the other one, if you pick lithium-7 to be your X calculation through the algebra would equal to 92.51 first. And then you would use the same steps using 1 subtracting 92.51% to get 7.49%. All right, so hopefully that helped you. And stay tuned and please like the video so that let me know that this video had helped you, and I will see you in the next video.